Okay, I'm still seeing people come in, so I'm gonna let everyone have a few more minutes. But as we get going, welcome everyone to this NSMA webinar. I'm going to start sharing my screen so we can get our presentation pulled up. And in the meantime, Joe Sandri, our awesome NSMA president, will be leading us in introducing Cathy Sham with the NASA Johnson Space Center. So thank you so much for everyone for being here with us. And Joe will get us started.
Great. Thank you, Mariana. And I am more than honored to introduce Cathy Sham. Cathy did some initial presentations for us at our annual meeting this past May, and we're very excited to have her. Cathy is a lunar spectrum manager with NASA. And, you know, with her increased lunar activity, the NASA Lunar Spectrum Manager serves as a focal point for spectrum coordination activities in the region. I'm going to give a quick high level of what she does, and then we're going to jump right into Cathy's presentation, and also do a quick background on what the National Spectrum Management Association is. Again, welcome everybody. So Cathy Sham is a NASA Lunar Spectrum Manager. She facilitates frequency pre-coordination to promote maximum compatibility and effective utilization of allocated radio frequency spectrum by all NASA projects, missions, planning lunar-related activities, including all commercial and academic activities funded and contracted by NASA. That's obviously a very big job. This includes identifying and studying spectrum concerns to support future lunar mission needs. She's with the Johnson Space Center as a spectrum manager as well, a NASA Human Space Flights Program for ISS systems, IP commercial external interfaces payloads, working with Orion, SLS, commercial crew, Lunar Gateway, lunar surface systems, EVAs, commercial lunar payloads and experiments, and of course the associated regulatory matters and JSC local operations. She's chairman of the I2R working group Party 7B and is exceedingly busy with that. So we're super lucky to have her here. That's the Space Radio Communication Applications Working Party. She's chairman of the Lunar Martian Spectrum Group, the LMSG, at the Space Frequency Coordination Group, which is also known as the SFCG. Again, welcome, Cathy. We're more than honored to have you here. We are spectrum frequency coordination professionals, and some of us are actually spectrum nerds, and we love this stuff. So welcome aboard. Quick high level, NSMA, National Spectrum Management Association, was created at the behest of the Federal Communications Commission. We are a group international in scope. We're voluntary. We've been established since 1984. We have members through federal agencies across not only the U.S., but internationally. We have members in industry and academia. And this is the center point, the center of gravity for spectrum management professional discussions. And again, we are kind of the linkage between government regulations and industry practice. We develop guidelines. We help try to streamline them. We always like to be at the forefront of understanding the big issues and the small wedge issues. Of course, this is a monster issue. This is lunar spectrum coordination. You can only go out from there. And again, welcome, Cathy. We're so pleased to have you, and I'll turn it over to you.
Thank you very much. Thank you, Joe. I don't know if, okay. Here we are, the beginning of my presentation, and thank you, Joe, for your invitation. And I want to welcome everyone to this webinar, and good day. Again, my name is Cathy Sham, and I'm honored to have this opportunity to come and share with you NASA's lunar mission spectrum planning and pre-coordination process that we have been following over the last several years. We recognize that there's this unique environment in the lunar region, and with limited spectrum resources that we want to make sure that we use it wisely and take into account all the different missions that would be operating in this region. And perhaps we should go ahead and maybe go to the next slide. So here you could see that starting from the left side of the screen, it's a quick rundown on in 2021, and actually, as you know, that through all the news and different activities that you've seen being reported, that there's actually this activity for the lunar missions have started several years before 2021. But just in 2021, now we're only in September, that we have commercial activities, we have NASA private partnerships, and we have missions from civil space agencies around the world. And here you could see that it's a very busy place. For a while, the moon was not so popular, maybe let me put it that way, but since a few years ago, renewed interest and also NASA's Gateway program was stood up to start looking at the moon as an opportunity for future planetary human missions. So, as you know, that NASA's Artemis program is looking at landing the first woman and next man on the moon. And today, we are working on the first unmanned or uncrewed mission of Orion to the lunar region. We are looking at early calendar year 2024 with the current planning activities. And so with astronauts, with preparing Orion as the transportation capability to take our astronauts and in the future, non-professional space travelers, hopefully, into space to the lunar region and potentially beyond. So, so the Artemis program is what we view as a stepping stone. Astronaut transportation currently planned via Orion to the lunar region. And then we also have, as you probably heard, the human landing system that would take astronauts from the lunar orbit onto the lunar surface. So those are two things that NASA is actively working on to make it a reality in the several years to come. And of course, we also need to have a lunar base first in orbit, and hopefully we will be putting a lunar habitat on the surface of the moon, eventually to support sustained man presence on the surface. So, so with that, as you can see that even near-term activities would require spectrum and spectrum coordination between the different entities is critical for us to make sure that the spectrum is effectively and efficiently used, and also that we minimize any potential interference. We do not want to have a space mission that discovers that there is an interference issue after it's in orbit. We will want to know that as early as possible during the planning phase and find a solution for such a problem as early as possible. So also on this slide, you see on the right side, the Artemis Accord, which is an agreement between many space agencies, including NASA, that we are to facilitate exploration, science, and commercial activities in the cislunar space. And in order to do this, spectrum planning and pre-coordination is certainly a large part of that, in addition to obviously spacecraft and hardware that would be put in the lunar region. And NASA's Lunar Spectrum Manager role was created for the purpose of making sure that within NASA, the many, many different programs, both robotics program and human space flight programs, are planned in an integrated manner, and also with our space agency partners who are flying or planning lunar missions, and also our commercial partners and beyond. With that, let's move on to the next slide. So here you could see that we have a diagram that provides the a peak of the lunar spectrum environment. And from the left side, you will see that there are lunar orbiting missions. By our count, here's actually not a complete count, but as you can see that just science missions, we are anticipating a number of them. And the ones that you see kind of on the middle left side that are listed are missions that actually will be on what we call Artemis 1 mission, excluding the Chang'e 5 and 6, which is from the Chinese Space Agency. And that is already in operation. Actually, Chang'e 5 is a sample return mission that have returned, and Chang'e 6 would be is in the planning stage. And the other ones that you see up there, the 5 are NASA and our partner agency missions that will be going with the Artemis 1 launch early next year and be deployed in the lunar region. And it would obviously have communications link between these spacecraft and Earth to support its mission objectives. So the other thing, moving kind of towards the bottom, as you can see, bottom of this slide, or lower part of this slide, we have lunar surface missions. And there are rovers, there's EVA, there are envisioned HAPS in the long term. And so all of these elements on the lunar surface are expected to have communications link between these different elements on the lunar surface, and also to a hub or a comm station, which would relay communications back to its individual mission control center. And then you see that in kind of the middle towards the right side of your screen, there's potential transportation vehicles that would be going back and forth that we envision eventually for potential commercial space tourism between Earth and the lunar region. So those spacecraft will require communications as well. And of course, the complement of Earth stations that are currently operated by different entities, space agencies or commercial networks. And with this, you could see that it is not one entity communicating with its own ground station network only. It is multiple entities performing their own missions in the cislunar space or on the surface or from the surface, which requires communications back to Earth And they may or may not, based on the current model, that you will know about them until you see these missions potentially through a filing, or once they make some announcement in the news. So the overall goal of NASA's pre-coordination for lunar missions is to enable the ability between different entities to come together and discuss and come up with a mutually beneficial plan so that we don't cause interference to each other, and we could effectively share the spectrum that is currently allocated for use from the cislunar space. Next slide. And this slide give you a slightly different view of the missions from the standpoint of when they would be launched. And these missions here obviously are not all inclusive of missions in that will be going to the lunar region, but these are missions that have been a part of the lunar spectrum planning process. Either they are NASA missions or NASA partner missions, or that they are space agency missions that that we have coordinated amongst ourselves, so that we know what each mission frequencies are and what their plans are, when they're going to be operating, and what their requirements are. And if for some cases we have had to come up with a coordination process, in some cases, we've had to make slight adjustments to center frequencies and bandwidth to ensure that both their compatible operation and also that they also comply with the regulatory requirements for use of certain spectrum. So again, you could see that the spectrum is quite busy, or that this lunar landscape is quite busy from a spectrum perspective, which brings us back to the point on why NASA is strongly advocating early frequency planning and pre-coordination at the earliest possible stage of a mission, and that our partner agencies have all agreed and to this mutually beneficial process. And I believe we are coming up on a question and answer break. I would be happy to take any questions that you may have.
Great. One question, Cathy, was, given the complex environment that you're dealing with, are you seeing that there's a spectrum manager for each type of element? For example, the high altitude orbit and the lunar relay orbiter and the potential commercial space tourism and other entities? Or are you seeing that you're dealing with a spectrum manager from a variety of organizations that handles all of those issues? How is this coming to you?
Yeah, thank you, Joe, for asking that question. Indeed, this is a very complex issue. And currently, we recognize that each mission or entity would likely have their own spectrum manager who would assist the mission in the initial decisions or provide guidance to the missions on available spectrum. and that their spectrum managers or these individual element or system spectrum managers will also be the person to help the mission in through their regulatory process. The NASA Lunar Spectrum Manager is not designed or not intended to be involved directly or in regulatory filing. This is really more of a technical pre-coordination, which we hope that we would have the opportunity to work directly with the individual missions, of course, or through their spectrum manager. The reason for that is because we wanted to make sure that there's an opportunity to understand what the exact requirements are, and also to be able to provide frequency options based from an integrated view. Because while it may make sense to have the different orbits do their own coordination, one of the issues that I think the basis that we need to remember is that spectrum allocated today for use by missions that will be going into the cislunar space or even from the lunar surface to Earth are shared. There is no distinction. Unlike near space and deep space, there's a distinction. There's no distinction between lunar region or cislunar space and Earth orbiting, for example, missions. And so because we are going to be sharing the same spectrum, it is essential that at some point we integrate those desired uses so that we don't neglect compatibilities with one kind or the other. Again, goes back to there are multiple steps to take. So certainly we recognize that individual spectrum managers would probably start the process, but the process that we're talking about here is intended to cover the integrated aspect of all missions in the lunar region.
Thank you for that very thorough answer. And, we're all quite curious as to how you're able to fold together and dovetail all that complex environment. And that's very helpful to give us at least a initial snapshot into your environment. And I think that covers the Q&A break for now. We have other question and answer breaks throughout. Thank you so much.
Okay, thank you. Thank you. So with that, I want to move forward to here you see in front of you the Lunar Spectrum Manager function. And one of the things that before I'm not going to read a slide, but one of the things that I wanted to share with you is that through NASA's human spaceflight mission experiences, especially the International Space Station, due to the large number of entities involved in on the ISS. Early on, we began with a few space agencies, but today we have not only space agency systems and experiments on board the International Space Station, we also have academia and commercial payloads that are being hosted or deployed from the International Space Station. So that gave us a good idea of how to deal with systems that are being developed by different entities, potentially starting out with different sets of local, if I could call it that, local regulations. Because as you know, as spectrum managers said, the US domestic regulation and the frequency table may not be the same as another country's regulations. But ultimately, we do have the international table of frequency allocation that flows down, or that that is the initial basis for space, for systems operating in space. We're not limited, as you know, to domestic regulations, because depending on what your system requires and who is your intended receive location, or where your intended location, receive location is, whether in space or on the Earth, we are going to have to pay attention to international regulation. So for space systems, we do ultimately obviously go to the ITU, and it has to be filed. So before we do that, it goes back to kind of my answer to Joe's question during the Q&A session, is that one of the big role of Lunar Spectrum Manager is to make sure that the applicable policies and constraints pertaining to operation in the lunar region is understood and understood equally across the board, not and so that there's no question as to what needs to be taken into account. And of course, one other function is frequency selection. We are not expecting that frequency selection strictly being done in a centralized manner, but we could certainly provide, we meaning NASA can certainly provide that support as requested and if necessary. So individual missions, knowing what the applicable spectrum policies and constraints are for operation in the lunar region, can certainly perform the analysis and provide the frequency options that are under consideration for the purpose of pre-coordination. And so that would be sort of the first step that we hope that more and more missions going to the lunar region would take that first step to pre-coordinate frequencies that you're intended to use. And if necessary, NASA could provide support to provide options that for your consideration or for your project's consideration. And again, we leverage heavily on what we already learned from our past experience to minimize impacts for our missions, because we also recognize during our years of experience through International Space Station that operational workaround, while it is a mean to mitigate interference, it is time consuming and resource intensive. And sometimes it actually doesn't let you do what you need to do for your mission because of these issues. And we learn also that some of the issues could actually have been resolved while the system is still on the ground, rather than resorting to operational coordination. And so we really firmly believe that operational coordination should be the last resort for mitigation, because as you all know, as spectrum managers, and you understand the existing regulations, that at the basic level, that these regulations were put into place not randomly. There were studies that were done many years ago to provide the general basis for making those type of allocation. We don't put two services together that we know that they're going to be in conflict by definition. So following the regulations and ensuring that your design meets regulation is one of our first goal in these type of technical coordination. And of course, we would use this forum to be able to help missions to achieve its goal compatibly with other missions that are going to be operating at the same time in the same space. And the Lunar Spectrum Manager will track these activities that we have coordinated or been involved in the coordination, and make sure that we keep everybody, all the other missions aware. And of course, they will be the basis for new missions coming in. And if necessary, we could also support post-launch interference resolution as needed. With that, let's move on to the next slide. And this slide is intended to give you an idea of what it looks like to conduct a pre-coordination with the Lunar Spectrum Manager. If you look at the diagram to the left side, you will see the turquoise 3 blocks. Those 3 blocks, NASA, other government agencies, and international civil space agencies, which is the Space Frequency Coordination Group, as Joe had mentioned earlier. These 3 blocks shows you the entities that currently engage in pre-coordination of our missions. We have been doing this for many, many years, and the space agencies, and also between NASA and other federal government agencies, we have learned and appreciate the ability to do this pre-coordination early and discover problems regarding frequency use at the earliest possible stage to affect changes before a mission is at the phase where it's really kind of too late. You already cut all the metal, put the satellite together, put them on the launch spacecraft, etc. So we have found this process, while time consuming, because we do require upfront investment from the involved missions to make sure that we spend time and time of the engineering staff and teams that needs to be involved in this process very early on, so that we could assure to minimize any impacts down the road. So this slide, what we're showing here with the LSM on the bottom, and with lines to all the boxes here, is intended to include commercial sector within the US and non-commercial sectors outside of the United States. And all of this is below or before we get to the regulatory process. And this model has worked well with the International Space Station. And we hope to be able to use these experience and the same model for missions that will be going to the lunar region. So I think that's all I have on this slide. And I think we're coming up with another Q&A break.
Yes, thank you, Cathy. Those slides are really helpful to break down and help us understand the big picture and the complexity. One of the questions was, I guess there's two questions. I'll just put them together and you can answer them as you see fit. One is, obviously it sounds like, that measuring twice and cutting once, is so key. And of course, even with that very, very careful activity, sometimes there's a post-launch interference resolution assistance need. And so, one, are there some examples of pre-launch where you found, a significant issue and you were able to iron it out? And do some of those involve NASA being requested to do some frequency advising in terms of a particular frequency to be utilized? So that was one question. And the other was, what's an example of a post-launch interference resolution assistance program that you think is a good model?
Okay, thank you, Joe. So the first part of it regarding the pre-launch activities that allowed us to discover issues and be able to address them prior to launch. I can give you an example of even within NASA. We have systems that are going up to the International Space Station or that we are planning on launching down the road. And through the pre-coordination process, even within NASA, we have discovered that potentially a payload actually uses a frequency that could potentially cause interference to the launch vehicle or vice versa.
Wow.
Because as you know, launch vehicle may or may not be involved with a integrated design effort with the payload itself. So we have learned that, or we have found actually cases where it was not discovered until an integrated test, which was quite late. It's not as late as being on the launch pad, but it is late because you obviously have built your system. So those are situations where, which we really believe that in hindsight, analysis early on and paying attention to what we call the integrated stack is critical because obviously there are multiple engineering teams doing what they need to do. And usually systems who are the system engineers for that particular element may or may not be aware of another system that are being built. So it is important that we have these, have ways to know what other systems are also in the planning phase. And while it also works for an individual system to go out and find and talk to everybody else, that doesn't seem to be an efficient way of doing business, because then we're requiring, for example, system A engineering team to know about, B, C, D, and E, and all vice versa. And that's just a lot of information. But because each system already need to provide their frequency requirements and identify spectrum use requirements through the spectrum manager, that is a way that we have found to be able to, at the sort of the high level, first discover whether or not there's a potential overlap. But overlaps are not by definition a bad or a terrible thing, because it all depends on when you're going to use it, how you're going to use it, who you're going to talk to. So those are things that we have learned that spectrum managers could help the individual missions and projects to identify and bring to them the issues early on. So I hope that helped answer or provide some examples.
Oh, for sure. And that sounds so critical, the integrative testing and the integration stack analysis. Mm-hmm. And it's great to see, that those processes are in place, of course. And of course, NASA seems like the home for such a critical piece of the puzzle prior to launch, especially. Yeah.
Thank you, Joe. And I think there's a second question about the interference mitigation post-launch. Yeah. And we have actually also been involved with our other partner agencies in such an investigation post-launch. This is not something that you would want to have, because you try to do the best you can in advance, but inevitably there may be something that in reality it actually result in an interference scenario that was not previously discover, or that we were unable to really predict them. So when that happens, NASA have been involved with our partner agencies using variety of means to identify potential interference sources and determining which path or methods that we could resolve the interference. And of course, we have continue to have some interference issues, of course, but we have been definitely involved in. We have resources and partners we could reach out to help resolve those issues.
That's good. And obviously it's important to have such a facility ready in the event, because of Murphy, the inevitable, there's always something, and it's good to know that there's an institutional process there to help resolve and mitigate. Well, thank you for that. I think that kind of covers our that Q&A break. Thank you so much, Cathy.
Thank you. And the next item I wanted to bring to this group's attention is to a portal that we have put into support of this lunar spectrum management process. And this portal is not a database, but it is an interface to allow mission operators or mission planners to provide your specific mission parameters or requirements, so that either you could request NASA's assistance to provide frequency selection support, or to request NASA's support to facilitate pre-coordination with other lunar missions. And so, this is a system, or this is a capability that will require people to submit and request a user ID and login access. And you can see on the right side of your the slide, it provides you the link to gain access to the portal. So that once you do that, you will be able to get access. And this portal also has information on regulations and policies and other documents. It contains lunar region missions that we have been involved with coordination, give you some high-level information on what they are, and it also provides you the pre-coordination process and give you the steps that's necessary to be able to be a part of the lunar pre-coordination process. I don't think I have anything else here, but if someone had questions about the portal, we will take those questions and be able to answer your questions about the portal. And we could move on to the next slide. So here's a break, and I want to offer this to see if there's anyone who have any specific or direct questions on the portal at the moment.
I don't see any specific question on the portal. I know, I'm sure people are taking notes, and that's very valuable information, and I think people are quite appreciative of that. Maybe just really quickly, do you have, when it comes to the portal, is that manned or staffed on a 9-to-5 basis, or how is that typically managed?
Well, the portal is electronic, and you could go in and you could use or look at the material that's available there, or that you could submit your mission information for assistance, essentially. So it's not necessarily I guess there's nobody really for you to talk to directly, but we would make sure that that the questions are answered promptly.
Thank you.
And so here we come to the takeaway. As far as the takeaway is concerned, I think I cannot overly stress the importance of early technical collaboration through these mutually beneficial discussions that we can work on requirements and identify spectrum that can support the different functions and to achieve your mission objective. And we are also, as I indicated earlier, to identify possible technical and spectrum licensing issues, so that ahead of regulatory filing, then there is an opportunity to address these issues upfront, and so that you don't see the additional delays that potentially is almost out of your control, direct control, because it would be in the regulatory regime. And as far as the benefits are concerned, working with NASA's Lunar Spectrum Management team, we will be able to assist you in frequency selection as needed and as requested, and also definitely facilitate pre-coordination with other missions. And here, one of the things that being part of the process is in providing your mission parameters and mission CONOPS, what allowed us to take the first step in analyzing and identifying whether or not there's conflict. And that information will be fed back to the mission so that you would have an early opportunity to make a determination on what you will need to do or what you want to do from your individual project and program perspective. And the biggest thing is to minimize delays and rework during equipment certification and licensing effort. Because typically, by the time we get there, it will be costly, both from a monetary and schedule perspective, to have to rework what you have spent lots of your time and engineering efforts in. And finally, this portal is a central platform that we hope would be greatly beneficial to all who wish to participate and to provide the responses that's necessary to support each mission. Next slide. Thank you.
Cathy, that is an incredible amount of information, well, crisply stated. I'd like to state, that we have a lot of people who ask questions who come from the CubeSat environment. They're doing tiny little projects, very important to them in the academic environment or clubs and things like that. We have satellite mega constellations, the largest networks known in the history of man, which have now been approved, in the history of humankind, which have now been approved and are now being scheduled for launch and are being launched. We have, as you well know, different international GPS systems out there already launched. Some are still under construction. We have the space tourism movement. We have the space mining, increased cadence on the space mining requests and research. And all of this is coming, together. And, here we have NASA at the center of it with live, personnel on board trying to advance not only new lunar missions, but also, as I think you mentioned, there's discussion about moving to Mars and beyond. And so some of the questions sort of come together in a way where if you were queen of the world, what would you desire for helping bring all this together? Do you have the resources you need? Is there something else you're seeing that would be amazing to have? What are your challenges in that kind of environment?
Yeah, thank you, Joe. I think one of the biggest challenge, as you indicated, is resource. But I think that the collaborative spirit within the spectrum management world or community is one thing that is that is going for us, I guess, if I can put it that way. That the willingness and the support that we have to conduct these early coordination and really think about a win-win situation for all would really help us in going forward and help our missions be successful. Of course, the other thing that I think we all also need to be thinking about is we all know that spectrum is a limited commodity, and that if we see that there are new spectrums necessary to support missions in the lunar region or beyond that is not currently allocated, efforts would need to be started to think about what needs to be done, because we all also know that this is a long process for obtaining additional allocation that has to go through a World Radio Conference. So early planning, I think, is the key that, and we all know well. I also would say that having these kind of opportunities to come together and to look at what missions we have and what are all these missions are doing is one thing that is helping us make sure that we do the best we can together in order to help we advance in this area for our missions. So thank you.
Thank you so much. The the value of this discussion, one is, all these nice crisply stated slides. Two, seeing the face of NASA, and I know you have large teams you're coordinating with, having the resource and learning more about access to the portal. And of course, that continued emphasis, we can all go back to our people who help each one of our, there's dozens and dozens and hundreds of spectrum managers that Nsma as members, and everyone can go back and talk more about, making sure we're doing careful early stage planning. We're building that into our calendars and our resource and budget planning. And those are all great takeaways. The other great thing about this is, we can replay this. People can look this up and say, oh, I remember that webinar, or oh, maybe our team should review this prior to getting involved in some aspect of whether it's a CubeSat or a large scale constellation. So, very happy to have you here, very excited to have this discussion, and it's good for posterity. We'd love to have you back if and when large developments come on to your calendar and you have something you want to share with the community. And we greatly value your time and attention today. And thank you so much for being here.
Thank you. Thank you for this opportunity, and thanks for all who have participated. And please do contact me if you have any questions and that needs additional offline discussion. So thank you.
Thank you, Cathy. All right. And thank you, Mariana. And this concludes.
Thank you, everyone.
Yeah.
Thank you so much, Cathy.
All right. And this concludes today's webinar. Thank you so much.
Thank you.